Hi, everyone, and welcome to Backer Breaks It Down. In this episode, we are going to take a look at triangle similarity. So, if you're given two triangles, can you determine whether they are similar and then explain why they are similar? So, I had you do a little investigation. Okay, so I had you explore all three similarity theorems. The first one being the angle-angle similarity theorem, simply known as AA. And it says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay, so I need to know that two pairs of corresponding angles are congruent to say the triangles are similar by AA. And so I had you guys take a look at these two triangles, and I asked you, are these two triangles similar? So let's see how you did. Okay, so I determined that yes, these two triangles are similar. I used my triangle sum theorem, and I determined that angle C is 79 degrees, angle H is 35 degrees. So I know angle A is congruent to angle H, angle B is congruent to angle G, and angle C is congruent to angle M. Thus, I can say triangle ABC is similar to triangle HGM by the angle-angle similarity theorem. The side-side-side similarity postulate, simply known as SSS. It says if three sides of one triangle are proportional to the corresponding sides of another triangle, then the triangles are similar. Okay. Now, my advice when you're like exploring whether or not side proves similarity is to list out the sides of your triangles from like shortest to longest. Because doesn't it make sense that like the shortest side of one triangle corresponds to the shortest side of the other, and like the longest sides correspond as well? So I think that's the easiest way to like set up your ratios is to go from smallest or shortest to longest for both triangles and then reduce those ratios. And if they all reduce down to the same similarity ratio, we can say the triangles are similar by side. Okay, which is what I had you guys do here. I wanted to know if DEF or GHJ was similar to ABC. Okay, and you're given information about the sides. So side, similarity is the way to go. And so as you can see over here on the left, I first compared triangle ABC and triangle DEF. So I wrote down the sides from shortest to longest. And I like did that for both of those triangles, and they all reduced down to be 4/3. So I'm like, oh, the corresponding sides are proportional, therefore triangle ABC is similar to triangle DEF. I did the same thing over here with ABC and GHJ, and I determined that those three ratios did not equal each other. Like all three of them have to equal the same, like all reduced down to the same, and they didn't. Okay, so A, B, C, and D, E, F are similar by side. And then there's side, angle, side. It says if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides that include these angles are proportional, then the triangles are similar. So remember when we were talking about congruent triangles and side, angle, side? And I said like all three pieces like have to be connected. Okay, same thing applies here. So notice here I am like determining whether the corresponding sides are proportional, and I've got the included angles that are congruent, making these triangles similar by side, angle, side. So I asked you to determine whether or not these two triangles were similar by side, angle, side. And yeah, they have that like angle T is congruent to angle L, but are the corresponding sides proportional? That is the question. And I determined that they weren't. So I went from like shortest to longest for each triangle. I reduced those ratios and I got 4/5 and 3/4. And those are not the same, so they're not proportional, and therefore the triangles are not similar. So those are like the three ways we can determine triangle similarity. We've got the angle similarity theorem, the side angle side similarity theorem, and the side similarity theorem. And that's how Backer breaks it down.